Now, the idea behind trigonometry is not to go around calculating trigonometric ratios for every angle. No, trigonometry is used because the sine, cosine, and tangent ratios are already available for every angle, no matter how small. And using the ratios, we can then find all the sides and angles of triangles by only knowing the measurement of one angle and one side. In other words, trigonometry is a better tool to answer questions about triangles because we can solve problems faster. And where do we find these ratios for every angle? Well, in the past there were books of tables and slide rules that had trigonometric ratios. Professionals like mathematicians and engineers always kept those tables and slide rules handy. However, since the advent of the handheld scientific calculator, tables became obsolete, and today the scientific calculator gives us the ratios. For example, in this triangle, this angle and this side are given. What we will do now is find the other two sides. This angle we can find easily because it is the complement of 36, or 90 minus 36 equals 54 degrees. Now we will use the sine because we know the side opposite to the 36-degree angle, and the opposite angle is part of the sine ratio. From the calculator we find the sine of 36 degrees. It is 0.5878. If we set up the ratio for the sine, which is the opposite side over the hypotenuse, the size of the hypotenuse will be found. So 0.5878 is equal to 208 over the hypotenuse. We solve for the hypotenuse AB by multiplying across. So AB is equal to 208 divided by 0.5878, or 353.9. AB is 353.9. Now, side AC may be found by the use of the tangent of 36 degrees, which is opposite over adjacent, or 208 over the tangent of 36 degrees, which is 0.7265. Again, by multiplying across, AC, or the adjacent side, is 208 over 0.7265, or 286.3. Leg AC is 286.3. Let's do one more example. In this example, we have a house that was built off the coast in shallow water, and we want to know, for rescuing purposes in case of a storm, what is the distance to the house. So we have drawn a triangle of the site, and on dry land we mark the distance of one side of the triangle. Distance BC is 75 meters. Using an optical device, we also found that the measure of angle B is 87.5 degrees. By applying the tangent of angle 87.5, we'll find the length of side AC, which is the short distance to the house in the water. Setting up the tangent ratio of opposite over adjacent, the tangent of 87.5 degrees is 22.9038. So 22.9038 equals AC, the opposite side, over 75, the known side. Multiplying across, AC equals 75 times 22.9038, or 1,718 meters. The distance from shore to the house is 1,718 meters, or a little more than a mile.